Mike Panaki here at Cisco Live 2023 in the Profitap booth. Voice over IP is great until it doesn't work right. And when it doesn't work right, everyone wants to know why as quickly as possible. In this video, we're going to take a look at how we can use the VoIP dashboard to troubleshoot and analyze voice conversations. So let's jump in and start taking a look at how we can use the voice over IP dashboard to evaluate our voice over IP health in our network and troubleshoot problems. So I got here by coming over here to navigate and selecting VoIP from that navigation menu. Now, here we see some calls that are going on our network. Now, some of these are bogus calls. They are people that are trying to get in from the outside world, getting into my network using my voice over IP, quite unsuccessfully, might I add. But here is a call that really took place. Now, the phone for this call is connected to the other end of a Starlink connection. So this is coming in through Starlink. Here we see how long ago that call occurred and how long that connection was established. Now, what I can do is I can come in here and I can click on the select button. And what this is going to do is it's going to start out by showing me the path the packets took to get from that phone to my IP PBX. And we can see which protocols were used along the way. So we've got our session initiation protocol, we've got our real-time protocol, comes in from the phone, goes into the remote network, comes through the internet, comes into our local network and to our PBX. Now I can go in and start drilling into that particular conversation. So I can take a look at my SIP response codes to make sure that I'm getting the codes I expect. So right here I see that I got a success. I would expect that from a successful voice over IP phone call. I can also look at my SIP flow details. So here I see my phone. My phone is talking to the outside IP address of my firewall. Let's go down even more. And these are the key values I'm looking for when I go in and analyze a voice over IP conversation. And here we see our packet. So we see a pretty consistent flow of packets. We're using the G711 codec. So it sends traffic even if there's no audio to send. Now I can come in and I can select that particular time frame. This allows me to zoom in even more and see what's going on in there. So I can see my packet data rate. That's fantastic. That's what I expect. And here I see that the traffic's going out at about 264 kilobits per second. Now, if I come down here, here are the metrics I'm really concerned about when I'm troubleshooting voice over IP. And the first one is packet loss. We need to make sure that as many of those voice over IP packets make it from one end to the other. So in this case, because each RTP packet has a sequence number, we're able to tell how many of those packets are lost in transit. So right here, if I select this time period right there, we saw 28% of the packets were lost. That's not good. Now, that was for a very short period of time. But as we come through, we can see, are we seeing packet loss occurring, and which direction is that packet loss occurring? The other metric that we really care about when it comes to troubleshooting voice over IP is jitter. Jitter is the variation in inter-packet arrival time. So what we expect is that we are sending an RTP frame every 20 nanoseconds. Now, if every one of those arrived at exactly 20 nanoseconds apart, our jitter would be 0. So in this case, we can start going through and taking a look at our jitter. The greater the jitter, the more likely it is that we will have degraded voice quality. Now, jitter can be caused by buffering along devices throughout the path. This can be caused by congestion. So here I can see what my jitter looks like in each direction. I can even come down and I can take a look at my calculated mean opinion score. Now, the mean opinion score is where these various metrics are combined together to give us a score. Now, an absolute perfect call would be 5.0, which we would never achieve with voice over IP. About the best I can ever expect is about a 4.11. So this shows me, even though I have some packet loss going on in here and I have some jitter, my calculated mean opinion score is about 4.11. That is fantastic. And I can even expand this out and take a look at the RTP streams that were involved in this. Now, sometimes we can't get everything we need by taking a look at the metrics. So if I wanted to be able to listen to this call, I could come up here and I can click on the download arrow. It is going to download that file. And if I click on that file, I can open that up in Wireshark. Here we see the packets that were involved in setting that call up and our RTP packets. I can go up to telephony. I can go to RTP and I can take a look at my RTP streams. I can select my RTP stream right here. I can select those two sides and I can say play streams, and this will bring this up and this will play that audio back. So if I hit play, it will play that stream back and I can listen to it to see what does that audio sound like. So the great advantage of using the IOTA for going in and troubleshooting my voice over IP is that I can come in here and I can go back in time. I can see what's happened. I could go back many days, weeks, if there's low enough data rate, and I can pick out a call that somebody reported was problematic. I can analyze that call by looking at the packet loss, by looking at the jitter, and I can even download it and play it back if I need to.